All right, welcome back everyone. I believe today is the 12th session of this journey of CentOS Linux 8.4, and today is 3rd February, and we will be discussing about processes, then performance tuning, and very brief about user space and kernel space. But before jumping into the topics, I want to tell you, I mean, few of the things that I discussed even on my last session also. So first, that is very simple. I mean, I believe you all know that is like we are on the 12th session, and as per the outline, we will have three more sessions, and the planned dates are 8th, 9th, and 10th February. So these are the planned dates, but if there is any changes, then we will let you know in your WhatsApp groups. All right. Second thing is like today this is a very important topic, but in these three sessions we will discuss three of the very, I mean, required topic, and very you should know actually whenever you are learning Linux as a operating system perspective, you should know, definitely know these things. So the topic is called SC Linux, and then scripting. We will learn about bash scripting actually, and then we will learn about little bit of cloud computing. So this is the high level plan for next three sessions, but today's topic is understanding processes, then performance tuning, and user space and kernel space. Let me do one thing. Let me quickly check if my audio is I'm audible or not. Yeah, I believe, yeah. I think the audio is working fine. All right, so let's continue. What are processes? What are performance? Everything. So let's go to the first session. What I told you on the first session, that we have hardware. On this side we have, let's say, hardware, and we have software, SW. Let's say software. What I told you, that whenever you want to manage this hardware, you want things to be faster, you want to do some kind of compute operation on these hardwares. So in that case, who is helping you? Ultimately, the helping part is happening because of your, what I told you, physical electricity. And who is controlling those electricity? Your different resistors, transistors we have inside them, and those are controlled by your software. This is the high level. I told you that whenever you want to manage the hardware, you need the software to manage the hardware. And why? Because we want things to be so much faster. But whenever you talk about the software perspective, what is software? What is the meaning of a software? So I told you that software is nothing but collection of files and folders. This is the very general meaning of software. Now these files are not normally your like video file or image file or audio file. These are normally called as program files. And what we need to do normally, we normally need to put these program files into your RAM. I told you this. Why? Simple reason is RAM. You all know that we have our storage devices. Like you have SSD, HDD, lot of storage devices are super slow. Like if you talk about the speed of storage device, we have, let's say, 100 mbps. Whereas if you go to RAM, then RAM is, let's say, 100 times faster than this. All right. So RAM is super fast. So if you talk about RAM, let's say if you compare it with, you will see it is 100 times faster. But when you go to CPU, you will see CPU is 1000 times faster. 1000 times faster from RAM. That's why you will notice that CPU is the most costliest device. CPU costs so much. And if you go to even to GPU, that is again on top of CPU, it will be, let's say, again 1000 times, or let's say 100 times faster. These are just imaginary. I haven't calculated these things, but Just for general term, or just for like your simple, very basic understanding, I'm giving these numbers to you. That's why you will see GPU is the most, I mean, you will know that GPU costs so much. Even they cost so much more than CPUs also. Now, if you talk about, let's say, RAM, what RAM actually look like? RAM, you know that RAM is just a small device, like this kind of device, and it has like all the, what do you call, like hardware related things, circuit and all those things. So they are helping us so that you can store your program file. Let's say you have one program file, let's say abc.py, and this is giving you output as a abc as a string. This is your program file. So as soon as you put this thing in your RAM, this is your RAM, what it becomes? It becomes the process. So it is not anymore your program file. So program file, it is there, it is in a storage, let's say in a hard disk. So it is there in a hard disk and it's known as program file. But as soon as it's reached to RAM, it become process. Why it is called process? Because process means, the meaning of process is set of instructions. This is the meaning of process. Whenever you combine some, let's say one instruction even, or let's say multiple instructions, those are known as processes. What do you call as process? Like you are, let's say you are cooking something, you are processing one, let's say dish for someone. So you have some set of instructions that you need to follow to make the dish. So similarly, process is just set of instructions. And why we need this instruction? Because CPU can only understand instructions. CPU is so much dumb actually. If you talk about CPU, it only know two operations. CPU know. That is, one is plus operation, and one is addition operation, and one is multiplication operation. So like one is like cross operation. So CPU is so super dumb in this case. CPU don't know so much things. So that's why you need to break down this complex thing, abc.py. You need to break down this complex thing into this format. And for that you have to do lot and lot of things. Then ultimately CPU know that it needs to do some instructions. It need to follow some instruction. Either do addition or do multiplication. So now the thing is something like, if you talk about CPU perspective. So CPU is doing these instructions. CPU only know those things. CPU is very dumb, you can think. And you have the RAM. But whenever you are like let's say you are calling this process, all right. So you call this process. Now, if you talk about RAM perspective, then just think logically. Someone needs to be there who will, I mean, send this thing. Let's say in your hard disk you have this thing, abc.py. So someone has to be there who will send this into your RAM and allocate a space there. Then someone will be there who will then send this thing to your CPU so that these instructions can be executed. So who is that guy that is doing this all the operations? So that is known as your kernel. Now, if you talk about Linux kernel, like Windows has their own kernel, Windows kernel, similarly Linux has its own kernel. So if you talk about Linux kernel, it's a very big file actually. This is nothing but a file. This is a file. All right. And this file, it has 29 million lines of code. Million lines of code. This file has. And it is keep on changing. Like there are lot of, changes are happening in this file. Right now, if you search on Google, you might see this number changed. Now, if you talk about Linux kernel, this is a simple file, but it has all the knowledge. It has all the interesting features, you can think, that it know how to contact to, let's say, those are called different files, or let's say different I can say, let's say, processes. And understand thing, these processors are not like your abc.py. These are very much customized processes that is running on your RAM. And these come again from some kind of file, and those files are known as drivers. So drivers are some kind of file which again go to RAM, become process. But these processes know how to contact to hardware directly. Let's say you want to play one music. So in that case, you have, let's say, sound card. That is physical hardware. You have, let's say, hardware, let's say sound card. Sound card. Now to play the music, you need to send some kind of electric signal to this sound card. Now how you will send the electric signal to this sound card? So for that, you need some kind of process or some kind of technique. So you need one kind of process, and this process is actually coming from these drivers. And who are managing this process? That is managed by your kernel. So kernel know how to manage all these processes that are coming from these drivers. So kernel know this. Similarly, let's say one of the driver is for your RAM. One of the driver is for RAM. Let's say this driver know that how to allocate space on RAM. So kernel first contact to this driver, and this driver will go to RAM and then allocate space. Alright, so everything is happening because of the drivers, and kernel is the manager of them. So when we talk about as an operating system, normally what we do, we divide this thing in two spaces, you can think. One space is called kernel space, another is called user space. Now if you talk about the kernel space, here if you see, you will find very much complicated files and folders. Very complicated these are. You will find that you have the kernel, and plus you have all the drivers. Those are DRI, VRS drivers, and all those lot of complicated C programming codes, assembly language codes. These are actually called low code, because these are very complex to understand. These are not like high level languages like your Python, C, Python, C++. All these are very low level code. But these codes are the reason. That's why we are able to work on user space. So user are who? Who is the user of operating system? OS. If you talk about the user perspective, it is not like human being is the user. No, human being is not the user. Again, these are again processes. Processes and files. But the interesting part is that these processes are run by us. We human being run these processes. Let's say you go start your mouse, and let's say you run abc.py. So this user space is running, let's say abc.py, let's say Python 3 abc.py, run this thing. So I as a human being log into my operating system, and then I run this thing. So this is happening in my user space. And then once I run this thing, then rest of the thing is happening because of my operating system. Operating system know that how to take the request from me, human being, take this request. From the user space, it will take the request. This is the input part. And then it will send that request to kernel, output part. Then kernel is running everything. Then whatever read output come up, it will then again send to OS. And then OS is sending back that to us, and we are able to see the output. But this is happening very quick. So much, in a speed of light, you can think, because electricity is super fast. Now, how This is the very general idea of kernel space and user space. But actually, if you talk about the kernel space, there are tons and tons of things actually. We can deep dive and we can learn about kernel space a lot and lot. But this topic, today's topic, is more about processes and how to see those processes, how to manage them, how to like as a user perspective. So that's why we are sticking in this space. So we are on our user space, and we want to manage our processes. So how we can do that? For that, first thing, understand that whenever you are booting the OS, how the boot happen. So first, let's say you have one laptop. This is one laptop you have, let's say. In this laptop here, in this point, you have, let's say, one physical button, and you press the button. As soon as you press the button, one signal will go because you have your battery. If the battery is dead, then this power button will not work. So as soon as you go, so one electric signal will go to your BIOS. And BIOS first will check that what is the boot order set there. So I am giving you very brief about this, how this thing works. So BIOS check that what is the boot order. So it find out that there is one of the hard disk, or let's say I'm taking nowadays people use SSD. So let's say one of the SSD, there you have your, let's say, operating system, let's say CentOS. CentOS 8.4 is installed. So now what it will do normally, so there is one of the concept called init RAM FS. So this is one of the file system, and that is initializing your RAM. So this is the first thing that will come up here. Now, if you want to talk about, if you want to learn about init RAM FS, we can do that. Will be discussion that we can do definitely. But let's keep on going and don't focus on this part, because if you focus on one single part, then the whole thing will be difficult for you to understand it. So just think like this, that as soon as you boot you like press the button, then you have the BIOS, then BIOS will go to the SSD because you selected what is your boot order, there is selected. It will see that there is CentOS 8.4 installed. Then first what it will do, it will contact to, let's say, it will in your RAM, it created init RAM FS, one file system it will create. Alright, so in SSD. Now let's say, now what it will do, it will first, after this init RAM FS, it will start the boot process, and the first process it will run, that is called systemd. This is the first process that as soon as you press this button, this whole process will run systemd. And one thing definitely understand, systemd is not coming under user space, because systemd, it is coming under operating system part. All right. So what I told you, user space, kernel space. So it is coming on this side, kernel space. It is coming on this side, systemd. So now what is happening? Let's say you have systemd. Now systemd know how to call different processes. It knows. Now what it will do, it will contact to, let's say, keyboard, let's say graphics, and let's say mouse, sound, Wi-Fi. So lot of different these are different processes. So these are different files actually, because you know we install the operating system on a hard disk, so those files are there. Now we need to put them on the RAM. Now it will first, systemd will generate this process, or like put all the files of this into your RAM. Now as soon as it put into the RAM, then these processes, now understand one more thing, as soon as these processes also run, so behind the scene everything happening because of the kernel. So systemd is also running because of the kernel. These processes are also running because of the kernel. So kernel is the backbone. So don't think like kernel we need to run, because as soon as you start the operating system, kernel automatically starts. So you don't need to like see kernel. All right. but you can see this systemd. So now what is happening, this systemd will now launch all these things, it launched. All right, and once it launched, then your screen come up and you know how to interact with the operating system, you know, login and all those stuffs. Now here I want to tell you one more thing. Let me click one more thing. Now let's say this is called, actually called chaining. So process chaining, SSES, process chaining. So process chaining is something like, let's say first what it did. So I told you that first you have, let's systemd. So systemd is a process and that is run by whom? It is automatically run by your your kernel and your operating system. Whenever you are booting the operating system, it automatically started. All right. So we are not starting it, systemd. Then systemd will go to different files. It will go to different files on your SSD. So it will, let's say there is one, let's say mouse. So it will put this thing in the RAM and mouse become on process. Now if now you as a user are using the mouse, let's say user, I am the user, I am using this process mouse, I am hovering my mouse in, then I double click on top of Firefox. Then what is happening, this process mouse, it will go to the file of Firefox, and then it will run the Firefox. So systemd is not running Firefox. Firefox is now run by this mouse process. So this kind of chaining operation is happening. That means if you stop this all will be stopped. But let's say if you stop this, still you have this. So that's why when you run the CentOS 8.4 in CLI mode, in that case you will see you don't have any mouse. You don't have mouse. But still you can do everything with your operating system. Why? Because these processes are running here. Let's say one of the process is terminal. Terminal is running. So in terminal you can give your commands and you can, definitely run them. So this is the actual, this process chaining is happening, and how you can see this. So to see the process chaining, there is the command called ps tree. So this is the command. So let me move to the practical. Here if I run ps tree, you will see this is the chaining is happening. All right. Now if you see, the first process it run is called systemd. And what systemd launched? Systemd first launched modem manager, then it launched network manager, then it launched audit D, color D, lot of things, and these are running in parallel. So don't think like this is the first, this is the, say, although if you talk about the operating system perspective, it also run the things not, a CPU cannot run everything in parallelly. CPU needs to CPU can run one thing in one go, but still systemd will launch everything in parallel with one's process ID. Now let's say network manager is taking 3 seconds to launch, whereas let's say you will see dbus d1 is launching in, let's say, 1 second, firewall D is launching in 1 second. So this thing can happen, and as soon as firewall D, let's say GDM is one of the process. GDM, as soon as GDM launched, GDM know it needs to launch this process. So GDM know, GDM session, this process is, then it is keep on launching, and as soon as it reach to this GDM session B, here it notes it needs to launch these things like keyboard, GSD keyboard, and then mouse, and then power. So this power means this power symbol. You see one power symbol. So these are different processes. So similarly, if you see, there is okay, so let me see, there is, look, first systemd first launched, And then again systemd is launching systemd. Systemd. Why? What is the reason? Because it is this systemd. Again, if you see here, let's say genome terminal, or let's say one of the, let's say, yeah, we can go with the genome terminal. So genome terminal is this terminal. So if you talk about this terminal, whenever I'm running this terminal, so this is run because this systemd and this genome terminal is the reason for this. So here again, as soon as I run this, what do you call this terminal, it is contacting to systemd again in the backend. Because I run pstree command, you can see pstree command, I run this thing in the bash shell, and that is run because of this genome terminal, and this genome terminal is coming because of systemd. So it is again connected to systemd. So systemd is keep on running. Alright. So first we run systemd so that we can launch these things, and then we also need systemd to keep on running, because there are a lot of things you will see today that is dependent on the systemd. Alright. So like here you have like systemd, you can see some of the systemd things. But yeah. So this systemd is the reason whenever you run systemctl command, if I quickly show you systemctl status httpd. So why we are able to run this thing? Because it is loading from the systemd. You can see user live systemd. So this is the space from where it is loading, and for that we need the systemd to run. Alright. Now let's talk about process monitoring. Alright. So process monitoring. So how you can monitor the processes? So for that, there are lot of commands actually in Linux perspective, but one of the command is called ps. ps is one command. Alright, so ps has lot of actually options. So it is something like, you can think this is same like in Windows you have task manager. Similarly, you have another command called top command. Another is w command. So there are lot of commands actually on respective. Even systemctl can also help you to monitor the processes. But let's see one by one. If I run ps, you can see it is showing on my current terminal. This terminal, what process I run? I run bash, I run ps. Because bash means this bash shell I run, and ps I just wrote here. Now if I there type sleep is a command. Let's say sleep 5 seconds, 2 seconds, or let's say 5 seconds. So it will freeze my terminal for 5 seconds. It will keep on running the sleep for 5 seconds, and then it exited. But if I run ps, you can see sleep is gone. But if you want to run sleep in the background, then we have one symbol called ampersand. So like as soon as you give this symbol, you can see sleep is running with 3302 process ID in background. But if you want to see where sleep is running, there is one command called jobs. So jobs showing that this is done, sleep is done. And if you want to, let's say I want to put this thing, let's say in 15 seconds, and sleep is keep on running. If I run jobs, you can see it is running state, on running state. Now if I want to, make this thing into the foreground, so I would fg1. So you can see sleep 15 is keep on running here. Sleep 15 is keep on running. So fg is for foreground. Like ampersand is to send the command to background, and fg is to bring it to foreground. So this is very simple thing, nothing to think about. But if you talk about this thing, ps command. So ps is showing you have bash and ps. These are the two things. Why? Because bash is keep on running here, and ps you just run here. Now if I run, let's say sleep in the background, let's say for 30 seconds, I run it, there is nothing. Now if I run ps, you can see sleep is keep on running. So this is one way, and with the process ID 3371. But you will notice as soon as like your sleep command is done, if I run jobs command, you can see it is keep on running. It is keep on running for the 30 seconds it will run. But to bring it to foreground fg, then you can see the number 1, So for that you can press 1, or if you want to, let's say for demo purpose, let me do one more thing. Let me type 115. Okay, so sleep 30 is done actually. So if I run jobs, you can see second one is running. This got the I mean this is another jobs ID. Jobs ID is 2. So in that case, I cannot type FG1 because it will show me no such job. So I need to type 2. So job has been terminated because sleep 15 is terminated. So yeah, sleep MP after 15 seconds consumed. But now if I run PS, you can see that sleep is gone from here. Now if you want to see all the processes, then there is option -A. So -A will tell you what are all the processes that are running in TTY2. All right. So in TTY actually terminal actually. So terminal, I mean the session actually. So session I have to tell you. So don't worry about it. But I want to show you. So if you go to help of it, just go on the help of it. So PS, what is showing? PS hyphen help. So PS -H, let me check if okay. So PS -H is also one option. So better we can do one thing. We can go to the manual of PS. So man PS we can do, and it will show us the manual of PS command. And here we can see lot of things, lot of options. And it is showing that to see every process on the system using BSD syntax, use PS then AUX. So okay, so let me do quick. So PS then AUX, just run this command and it will show you all the processes. All right. So it is showing that you are running lot of processes. And here I want to show you one more thing actually. So there is one very interesting thing actually in the terminal. This is also bash scripting concept, but yeah. So you can do one thing, WC-L. So 218 processes it is running right now. All right. So if you want to see, let's say there is one command called grep, and let's say one of the process, let's say okay, better will be I can run like, let's say sleep 30 in the background. I run this thing in the background. Now if I run PS-AUX, at the end you will see your sleep 30 is keep on running, and there is another sleep 60 is also running. So maybe I run sleep 60 sometime back, and PSX we run. That means each and every process it is giving one process ID, 333565 then 3573. So it is giving, and if you see this list at the beginning, the process ID will keep on decreasing, and at the 1, this is your system D. You can see systemd. This is the process that will run the first. That's why it has the PID or process ID is 1. So always remember, in Linux operating system, the PID 1 is for systemd because that is the first process we run. All right. So similarly, there are actually lot of options in PS command. All right. So let's say, okay, so sleep is done actually. So I run it in the background. So now sleep is done. So in the PS, let's say you want to filter out the output. So there is option -O, and then you can do like this. Let's see, let me check let me check which output I can filter out. So let me see this upper symbols actually. So you can see if you want to filter out the PID, then symbol is PID. For CPU it is %CPU, memory it is %mem. Then VSZ and then user. So these are the things you can, and you have, let's say, command. So these are the things you can filter out here. So filtering out is not a big deal. Like you can just quickly give PS- and give me only output of, let's say, user. So like okay, so why it is showing user defined format specifier unknown error. Okay, so let me quickly check actually, because man PS, let me actually check what kind of symbol they use, because this is rarely I also use. But yeah, here you can see it is showing you that you can use what are the options are there. Here you can see E0. Okay, so -O is the option. Okay, so I believe I'm using a little bit. Yeah, I got the point. It is showing me rather than you do like this, do like this -O. Why it is not showing? Strange. ps hyphen aux, and then it'll also show me the user, so hyphen o for output of the user, but why it is not showing me? Let me check actually again. We can filter to get security level, like here you can see we can filter the PID and press E for. Why they have E option? What is stands for hyphen E option? Let me check actually. Select all processes. Okay, okay, let me check if there has any more. I mean, let me check actually, because why the filtering is not happening. Let me go, keep on scrolling, okay, so here you have the options actually, hyphen c hyphen, these are the things, but percentage CPU, all the things are there, but don't they have any examples also? Maybe they have, so doesn't matter. Let me keep on going, because rather than wasting time, like I need to check why this thing is not filtering, but it should filter. I mean, I forget the syntax, rarely I use these things, but yeah, it should filter. I forget the option actually. Okay, that's completely fine, doesn't matter, because yeah, I can also forget, doesn't matter. But yeah, there are actually options to filter out these outputs also, so like I have to check actually, so I will tell you on the next class, doesn't matter, but yeah, I want to keep on going. So let's say you have another command called top, I told you, and once you run this top, so top is like your, what do you call, like task manager, you can think. So in top you can see like you have, let's say top, and then you have what is showing, it is showing one user is logged in, and then you have total 216 processes are running, one running, 215 are sleeping, all those things it will show you, and like it is also showing how much memory in totality you gave and how much is free, and it is also showing the percentage of CPU taking, like cell, this is the cell, our genome cell, this cell is taking 3.5% of the memory and 23.6% of CPU. It is keep on, I mean, changing. All right. Now in the top also we have lot and lot of options actually. So like one of the option, I think I have to check. Let me do the queue and let me do one top, then hyphen h if top has anything. Okay, so hyphen h doesn't say man top. Let me check manual of the top command. So if you want to see different options, let me check actually. Yeah, here you can see alt plus these things, or alt plus k for up, down, right, left. Okay, so this is for the navigation part. And if you want to see, let's say for a specific thing, so hyphen b, not this one. So let me check actually. Uptime, load, task, CPU, SY, percentage. Top command also have lot and lot of options, but these are the commands rarely I use actually. So I also have to check these things, like these options. Where it is actually. Control B or global symbol ABCD. I don't know. Okay, doesn't matter again. Like top you can do, and in the top there are options like maybe. Okay, there are options actually. So I will check this thing actually. So I haven't checked. I haven't got the opportunity to check these things. But yeah, top is again another command, very useful command actually. And one more command I told you, that is W. So W will tell you, like if you run the W, it will tell you what are the users currently logged in. And also systemctl definitely also tell you, like systemctl status. Then you want to say HTTP. What is the status of HTTPD? So HTTPD. So you can see the, I mean, status of HTTP, status of a process. So this is the very simple thing. But I want to tell you one more thing here. That is like there is another command called Netstat. I believe you all know, and TNLP. So Netstat is a command that will tell you about the network statistics, and also it helps you to understand which process is running. All right, like if you see here, one of the process called SSHD. So this starts from this line TCP/6 022 port number, and it is listening, and the process ID is 1192, and it is SSHD. So SSHD is running right now, and it is listening on port 22, and the process ID is this one. Now this is the, I mean, this is very general idea of processes, how to monitor the processes, how to see the processes. But if you talk about processes, if you talk about the PID, so this is nothing, what I told you again, that each and everything is files and folders. So PID is again some kind of folder, all right, in your, again, in your file system. So if you go to, like, in your file system, if you go here, and there, if you go to one folder, let's say CD, then proc is a folder. So if you go here and if you do ls, you will see there are a lot of folders, one, then all those things. So these all are actually your PIDs. All right. So let's say I run one of the process. So let me quickly run sleep. Let's say I run for, let's say, 300 seconds, or let's say I run for, let's say, simple 60 seconds, and I press ampersand. So sleep is running with 3934 PID. So now if I do ls1, here you will see 3934 will be there. So let me check actually. So 3460, here you can see 3934. all right. So if you try to go inside 3934, if you go inside it and if you do ls, you will see these all are the files. These are there on your RAM actually. So these files are the reason that your sleep command is running. And from here you can see lot of things like status. If you do one cat on status, you can see the different status of your, like what memory location we allowed to for our sleep command. And lot of things are there, threading, multi-threading, you know, like different things are there. And it is showing name sleep. You run the sleep command, PID is 3934, and then it is sleeping, state is sleeping, means the command is keep on on the background it is keep on running. So yeah, there. But if I do again do ls, so what is showing? No such process. Why it is showing no such process? Because sleep command is done. Now it is done. So that's why proc 3934 is not there. So if I do cd ... we cannot go there. Then we have to go to proc. And now if I do ls, you can see 3934 will be gone from here. So 3941 is there, 3978 is there. So 3934 is gone from here. All right. So PID is again like what do you call? PID is a number, but it is actually a folder. Inside that folder, you have all the files for your respective process. Now, similarly, let's say you want to manage the processes. All right, manage the processes. Manage the processes. So how you can do that? Manage the processes. So for that, there is one very interesting command that is called kill command. So kill is a very interesting command. So kill actually has a lot of features. So if I go here and if I run one of the process, let's say Firefox, and I run the Firefox in, let's say, background. So Firefox is running with process ID 4038. You will see within some seconds Firefox will be launched. Here Firefox is running. Now if I go to new tab, I can like search for anything. Okay. Now here if I type, let's say after Firefox, let's say what do you call, let's say kill command, and kill, and I type 4038. As soon as I run this command, you will see Firefox, it is exiting due to error channel, and my terminal hang up. Simple reason is, so terminated, Firefox is terminated now. So kill can terminate the process, but also kill has lot of features. So if you type kill -help, And here if it is showing that sig is a signal name, sig is a signal number. So it is showing that whenever you want to do something, let's say on one of the process, so these are different options we support on the kill command. One of the option is called, let's say one of the option is, let's say sig term. So sig term is for terminating the process. So signal term means terminate. All right. So if I do something like this, let me show you. If I do something like this, I again run the Firefox in background. 4400 process ID. Firefox is running on the background. Now here, if I type, let's say kill, and then I will give hyphen sigterm. So sig term is for terminating the process 4400. So it will again terminate the process. So by default, it will always terminate. But if I do something like this, let's say 4773, this is the process ID it give me. Now if I do something like this, rather than I give sig term, if I give sig stop, I'm sending the signal to stop the process. It stopped the process. Doesn't mean it terminated the process. Firefox is still there. All right, but it is stopped. What is saying? Restore session. I cannot click anything. I can go to activities. I can do like this, but I cannot do anything here on this Firefox. I cannot even close it. So it is freezed, one kind of thing. What is saying? Firefox is not responding. All right. Why? Because I freezed this. I stopped it. But if I want to continue this, so again, continue, CONT, continue. Type again, you can see Firefox come up here, and again Firefox started working. All right. So this is the thing with kill command. So kill has lot of features actually, and obviously I always suggest go to the internet and search about these commands. You know the command. Once you know the command, you can see all the options of it. Like kill has one of the option. Let's say what is the right now the status of it. Let me quickly run the jobs command and see what is the, okay, so jobs Firefox it is running, but what is the process ID I don't know. So in that case there is one option. If you want to see the process ID of any command, you can see I cannot see the process ID. Maybe jobs has some kind of option. Otherwise there is one option called pgrep. So pgrep is a command that will tell you the process ID. So 4773 is the process ID. How it can tell you? Let's say I run sleep, let's say 60. I'm running two things, 60, and let's say one of the sleep I'm running 120. I run two. Let's say I'm giving ampersand. If I run jobs command, you can see there are three processes running. So sleep 2 sleep are running. Two has different ID. One is 5198, one is 5227. But if I run pgrep on, let's say sleep, it is giving me that there are total 3 processes running with sleep command. So one is 5198, one is 5227, and another is 5190, maybe running in the back. On the previous time we run sleep sometime back. So pgrep is a really helpful command actually. So pgrep means process grep. Now if you see 4773, so there are actually different signal numbers actually. So if I go to manual of kill command, and if I show you those signal numbers here, so here if you see it is showing. So let me check why they haven't give the signal numbers. They should give the signal numbers, but if they haven't given that, that's fine. So you can see that definitely you can see the what you call. Okay, so Firefox is keep on running with the process ID. What is the process ID? pgrep Firefox. You can see 4773 is the process ID. Now here, if I want to terminate this process, rather than I do kill hyphen what do you call it, like sig term, I can do also like this -9 also. So 9 is same thing like whatever we did just now. Previously sig term, same thing you can do with -9 signal. So it again exited. So killed. You can see this time it is showing killed. All right. So kill is a very helpful command, and it has these kinds of signals. So you can send the signals to one of the process to like continue that, stop that, or do a lot of things actually. So now if we go to our topic for today's topic, if I go here, what are the topics for today? So I told you that what is the meaning of very basic meaning of user space and kernel space. I don't want to go to kernel space too much because it is complicated. All right, there are a lot of concepts like C group, unit file, systemd, tons of things are there. But if you talk about user space, there I also want to talk about another command that is very interesting command. So let me tell you the command name. You all know actually the command name. Command name is called systemctl. So if you talk about systemctl is a command, so systemctl also has a lot of options actually. So okay, so sleep 120 is also done. All right, so if I run systemctl status httpd, you can see what is showing. It is showing that Apache httpd is inactive. Now if you know actually about automation tools, so how automation tools come to know that this thing is inactive? So that's why normally in the backend they actually contact to the services in different way. But still, if you want to create your own Python program, let's say as automation perspective, in that case systemctl actually provide lot of option. So systemctl hyphen help, always take the help. Don't try to remember anything, always try to take the help. And yeah, so let me keep on pressing the. So if you see here, what is showing here, it is showing that there are two things: is active, is failed. So these are also two things, two commands actually in systemctl that help you. All right, that will help you to see the status. So status here type is active, what is showing inactive. Similarly, you have is failed. You can see again it is showing inactive. So similarly, systemctl has a lot more options actually. Let me show you some of the options. Suppose output global. Okay, so list unit is the units currently on the memory. I can also show you this also. So let's do this thing. So systemctl hyphen list unit. So unrecognized option list unit. Why? Systemctl hyphen help. Why it is showing unrecognized option? List unit files is there. Okay, list units. Okay, yes. Okay, so let me do the queue and units list. Okay, so this is this kind of option it supports actually. So what is unit file? It will be long discussion actually. What is unit file to talk about, like how these things are actually working, these unit files are working, like how they are helping us actually in the process. This is actually long discussion. Let me just close this discussion here, because like unit file I don't want to talk right now. All right, but I want to tell you one more thing. All right, so performance tuning I want to tell you. So okay, one more thing, let me also show you this also. This is also very interesting. That is cd/var then log. So if you go to this folder cd/var/log, it is a very interesting folder. This folder contains all the log of your operating system. And here if you see one of the file called messages, this is a very interesting file. Just read this file. If you try to read this file, you will see this file contains all the logs of your operating system. And let's say there one event happened. All right, so right now you cannot see any of the event. So let me do one thing. Let me open another new terminal, or let me do one thing also. So open another new. Actually, I entered in. So let me switch to this user. I switch to this user. All right, and then if I do su to abc user, and if I give, let's say, wrong password, I give wrong password. All right, So what is showing? Authentication failure. Now if I check the logs here, you see at the bottom it is showing started fingerprint authentication daemon failed SU2 ABC. So each and everything is happening in your operating system. All the logs are stored here. So this is very, helpful file actually. So logs, we need to, lot of times we need to check the logs, and there are actually lot of files. And here you can see mail log. So like messages, it is showing you messages is the current file, and these are the dates. So on this date, what kind of log generated, on this date, what we did, all the logs are there. So let's say one of the date it is showing, let's say 2022 22 means yesterday. So what kind of log it generated on the yesterday? Yesterday you logged in and generated some log. So let me read that log. So if I paste here, if I try to read here, it is showing that print the service succeeded, and then let's start see from the beginning whatever we did actually. So each and everything is there in this log. So let me keep on going up and up and up. So actually we did lot of practicals. So that's why some of the things you might remember. What is showing fingerprint authentication to daemon, then user mount, then session 2 of user root, and then like what do you call, like these are the things that you can see actually, but for that, like you have to know these things, like why these logs are coming, like starting hostname service. So what is hostname service, you have to know. But yeah, this is very, this is the file that we normally check whenever any kind of error happen in our operating system. We normally check these logs. So similarly, if you talk about, even if you talk about HTTPD also, that has also its own logs. So if you go to cd/var, so let me type var, then HTTPD, var log HTTPD maybe. So I'm on the, so here there should be one, let me check HTTPD, or let's say SSHD. So SSD is there, tuned HTTPD, you can see HTTPD. So if I go inside the HTTPD and if I do ls, you can see one thing, access log. So in this access log you have all the logs, like who access your server at what point of time. So there is nothing actually because my server is not running. But let's say I start the server, systemctl start HTTPD. I started the server, and then I go to my this activities, then Firefox, and I quickly go to, let's say, localhost. So this index file come up. That means the log is generated. If I go to my terminal again, if I try to do cat access log, you can see it is showing that from this point, this localhost, this is the IP address from where the log come up, and like someone tried to get operation on my HTTPD server on /path, and yeah, this is the thing it is showing. And one more thing, let me stop the firewall D. Although we can, write the firewall roots, but to save the time, ifconfig command I want to run so that I can track the IP address 192.168, then 126. So let me open one here. Let me open one new tab. Let me write 192.168.126. Where you can see index.html. So if I now go and check the same thing, same log file, you can see two entries come up. But it's showing that someone from the IP address 192.168.0.163 come up, and he did the get request, and he, from Windows machine and Chrome browser with this version. So these logs generated. And one more thing is, like if I type, let's say one of the, let's say abc .html, this space doesn't exist, HTML not found come up. Now if I check the log, you will see here it is showing it tried to do get operation, and I give the return code. Here you have return code 404. So previously it give me the return code of 200, 200 is success code, whereas 404 is not success. And it is also clearly showing that the user from this IP come up, and this user typed this thing in the URL http colon slashes, whereas if you see here, it is showing what I typed and what abc.html I tried to access. So this is the thing actually. This is about logs. But here, if you talk about the performance monitoring, you will see that if you talk about the Linux as an operating system perspective, let me check my voice is working or not. Yeah. So if you talk about as a performance monitoring, if you talk about Linux as a, Linux as a what do you call operating system. So Linux is universal, and Linux, why we use Linux? The simple reason is Linux is lightweight. Lightweight. What is the meaning of lightweight? You can even run the Linux operating system in like half MB RAM also. You can do that. That's not the challenge here. But the interesting part of Linux is for different use cases, we tune our this operating system. We can do that. Let's say some people wants to run, let's say hypervisors. All right. So what do they did? They normally use one very thin layer of Linux. Let's say one example is CoreOS. On top of this thin layer, they install the hypervisor. Let's say Zen hypervisor. And in bottom it, you have your hardware. So now this Linux, we don't need to install HTTPD. We don't need any mouse. We don't need any like extra features, because that will unnecessarily, take the resources from this hardware unnecessarily. We want this Linux to be so much optimized for only one purpose. So nowadays the concept is like use one service for one particular purpose. Alright, if you are using, let's say, one operating system, let's say CentOS 8.4, if you are using for your, let's say, HTTPD, only run HTTPD here. Don't try to run MySQLD. Don't try to run this. Don't do that. Don't try to even run SSHD if possible. Don't do that. Just run this. And tune your operating system in so much way, or even protect your operating system, or like give the security in that manner, so that this thing cannot be hacked, or this thing will run so much smoothly. All right. So that is called performance, not monitoring actually. Why I wrote monitoring? Let me write performance tuning actually. All right. So let me try tuning. So this is our duty. We need to fix first of all. What we need to do? So for that, there are a lot of things we can do in our operating system. We can limit the resources. We can limit our users also. So there are concepts like limiting user access. A lot of things we can do. But similarly, there is another concept. That concept called tuned. So tuned is a program. This is one program, and this program knows how to tune your operating system based on whatever profile you selected. So first I will go here, and here I will type. So let me go here, and here I will type yum install tuned, then -y. So it is installing the tuned. So once you install the tuned, it is not by default installed. So once you install the tuned, then first thing you need to do is systemctl start tuned. You need to start it, and you need to check the status. You can say tuned is running. And what is showing? It is showing dynamic system tuning. You can tune your system dynamically. And there, to handle the tuned, we have the command called tune-adm. Tuned-adm. ADM is the command. So if you run this command, what is showing? It has different options, and it is showing you, it has one option called list, it has one option called active. So if you run the active, what is showing? The current profile is virtual guest. Means currently it is working as a virtual guest system. But if you do the list here, you can see it is showing that these are different profiles I have. These are pre-created profiles. Like virtual guest is selected right now. Virtual host means it is showing optimized for running KVM guests. Means if you want to use your operating system as a hypervisor, then use this virtual host. Means on top of this you will install different operating system using VM, like virtual boxes. Similarly, there is one that is called, let's say, accelerated performance. Throughput performance based on tuning with disabled higher latency stop states. So if you want, accelerated performance, if you want the performance to be on one particular service, then you can do latency performance. So there are a lot of network latency. If you want the network latency performance, you can do, or you can do network throughput. So power save, if you want to save the power, then it will low power consumption. All right. So it is like different profiles they have. Let's say one of the profile is called desktop. So how we can set up the profile? Here you can see one option called active, and one option is called profile option. So using the profile option, you can even do that. So like tuned, then you can type profile and you can do desktop. As soon as you do this, it will change the profile to desktop. Now if you go to tuned active, you can see the profile is changed to desktop. Even there is one more option that is really helpful, that is called recommend. So recommend will analyze your operating system and then it will suggest what should be the best recommendation for like this tuned profile. So you can then change it to that also. All right. Now profile, you can give the virtual. Here you can give this virtual guest and then it will again revert back to virtual guest. All right. So right now it is active. So current is virtual guest. So this is how normally you can tune your operating system. There are also lot of concepts actually. So like if you talk about, let's say, one of the user, let's say RMIDY. So this is one of the user. Let's say you want to limit this user. All right, how many resources it can run, how many processes it can run. So in that case, you can control that using like user space concepts, and you can like control that using unit file concepts. So there are actually a lot of things to like performance tuning also. Performance tuning is not a small topic, definitely. But I thought if we are talking about the processes, like all these things, then having the knowledge is a good thing. One more thing I want to tell you, this is also one very interesting thing. If you run systemctl status httpd, if you run this command, you can see httpd is running completely fine. Let me fail this service. How I can fail this service? For that I will do very simple thing, that is, let me go to the folder. The folder is I think var httpd usr. I forget the folder name actually, so let me check. /var. Okay, sorry, I need to give /var, then httpd. What are the options it has? httpd it don't have, so maybe it is there on the usr also don't have. Varlib httpd, varlib httpd, varlib httpd. Let me go here, cd, and let me do ls. Why there is nothing? Varlib httpd. Okay, I also need to check actually, because I wanted to fail this service. So there I forget the folder actually for the httpd. So like cd hc let me do hc. Does it here? httpd folder actually, where I want to change the port number of the HTTPD. Mm, here you have one HTTPD. Let me check actually. CD HTTPD and let me do ls. Okay, here. So let me go to conf.d conf.d ls. So here let me like create one conf file. Let's say vim, let's say raktim dot conf. I'm creating. Here I give, let's say listen on, let's say one of the reserved port, let's say 85. Most probably it will fail because of the, what do you call, systemctl restart HTTPD. It will fail. Yeah, it failed actually. So now it failed. So what I want to show you, because SC Linux doesn't matter, but now if you run systemctl status HTTPD, if you copy this thing, if you, these are actually troubleshooting actually, so it failed actually. And there is one thing, very interesting thing called journalctl-exe. So journalctl is a very interesting command actually. Let me clear. And so journalctl-exe, this command is very interesting because this command will help you to understand why your SC Linux failed the HTTPD. All right. And if you see here, it is showing that SC Linux is preventing HTTPD from name_bind access on the top socket 85. For complete SC Linux message run, so this is SC Linux topic. I will tell you how to see the messages of SC Linux alerts, how to do this thing on the next day. I have to discuss about SC Linux, AU search, SC manage, and even I will try to show you like how to reset the root password, and if time persists then I will definitely show you. But yeah, these are actually troubleshooting things also, like if some process suddenly stopped, then how you can do this thing, how you can troubleshoot these things. Like there is one thing called sc module, this command, you can copy this thing and you can just run this thing. As soon as you run this, it will tell you. So okay, so the file I haven't created, I need to create this file actually using a search. And yeah, so there are a lot of things actually. I will definitely show you these things, all right, in the next class. So like for today's topic, I believe this is all I have for today. And I know that this topic is complicated actually. So well, like processes and then like user space, kernel space, this is the core of the Linux, and I also sometimes struggle in this. So there is nothing like I am very well versed about these things, like unit file and all those things. These are very hard topic actually. These are actually very hard topic in terms of Linux, but those guys who want to make their career in very core Linux, those who are very interested in like core of the Linux, they can definitely go very deep into these things and can learn all these things. But if you want to know very as a brief thing, then just remember very simple of the commands, very simple some of the commands. These commands will help you in longer run. So what are those commands that you can remember from this today's session? One is ps command. Always remember this command and the option ps-aux. Let me write ps-aux. Another command that always remember, top command. And another command that always remembers, obviously systemctl definitely remember, but another is kill command. Kill command always remember. All right. And like I tried to show you, like if you want to run anything on the background, any process you want to run in the background, in that case, like give the like command and then give one ampersand symbol and it will run on the background bg. And if you want to make it into the foreground, run the command fg, then whatever the id you have here, and use the jobs command to check the id. Jobs is command to check the id. And like these are the commands we talked about. Maybe tune ADM also. Tuned ADM you will use really, what do you call, rarely, jacket. So that's the thing. And yeah, that's for today's class. I mean, I know I might haven't properly described all the things clearly, because this is a difficult topic. But I suggest you, if you are very much interested in this, then definitely learn. I mean, there are a lot and lot of resources also, but this is a vast topic. So that's also one truth, that these are not a small topics. So that's all for today's, session. So let me go to the Q&A and check what are the questions we have. All right, everyone. So see you in the next session.